13.1, right triangle trig, aka SOHCAHTOA, which is funny, is because how many kids, it says, if you don't know it, look up. This will be left blank by so many kids. Anyways, so like the number 3, 4, 5, man, historically, when I look at this homework, 3, 4, and 5 are blank. The reciprocal of sine, it's in your notes. It's called cosecant. The reciprocal of cosine of x, well, that would have to be the secant of x. The reciprocal of tangent, that would be the cotangent of x. Right? Like, I don't know what's up with kids. All right, number 6, right triangle ABC with right angle C has a hypotenuse AB equals 7. Now, she has a right triangle, and there's a reason I draw the way I do, but put your angle of interest right here. And the reason I do it this way is because it's on an imaginary XY axis. So there's a reason I draw that way. Anyways, that's how we draw them. We're told that AB is 7, A to C is 4. You're supposed to draw the triangle, find the missing side length, and leave as a radical. And to find the missing side length, you're going to use something that we like to call Pythagorean theorem. A squared plus B squared equals C squared. Now, A and B are legs. So because my B's look like 6s, I'm going to make B be the 4. So A squared plus 4 squared is 7 squared. 4 squared being 16, 7 squared being 49. If we take 16 away from 49, I feel like we get 33. And then the opposite of a square shall be a square root. And we're only worried about the positive because this is a length concept. So root 33 is the missing side length. Now you're supposed to find all 6 trig ratios, and this is going to take a while. First off, we have the sine of angle A, and that would be the opposite over hypotenuse. So I'm going to take a minute and I'm going to label everything. If you look at 4, 4 is next to angle A, but not the hypotenuse. That's the adjacent side. The root 33 is the opposite side, and 7 is the hypotenuse because she is opposite of the right angle. So anywho, we're going to get root 33 over 7. The cosine of angle A would be the adjacent length over the hypotenuse, adjacent being 4, hypotenuse being 7. The tangent of angle A would be opposite over adjacent, so root 33 sitting pretty over 4. Now, here comes the fun part, the reciprocals. If I want cosecant, I flip this guy, and I get 7 over root 33. But then I got to go, aha, somebody in the 1600s said, hey, no radicals in the denominator. So I multiplied the top and bottom by root 33. I need to look up that dude's name. But anyways, a root 33 times root 33 is 33. So the pretty form of that number is 7 root 33 over 33. The reciprocal of cosine has always been called secant, and it always will be, and this one's easy to flip. You just get 7/4. The reciprocal of tangent has been called cotangent for a long time, and we have 4 over root 33. We clean that up by multiplying the numerator and the denominator by root 33, and we get 4 root 33 sitting pretty over 33. There we go. Moving forward. Let's look at number 8, because that'll help you guys do 9. Given the sine of theta is 2/5, find all remaining trig ratios. All right, so we draw a certain way. Of course, we don't have, this is not a named triangle. And here's theta. The sine ratio is opposite over hypotenuse. So opposite of theta is a 2, hypotenuse is a pi. But I wrote h. All right, now we'll find this missing side right here using a little Pythagorean theorem. Yeah, I'll just call it a for now. So a squared plus 2 squared is 5 squared. 5 squared is 25, 2 squared is 4, the difference is 21, so a is the root of 21. I'm going to go through and I'm going to do all my ratios. And I've got a whole bunch of them. I was told sine, so I don't have to write her down again. That is theta. Now the cosecant would be the reciprocal of this guy. Or you can just do cosecant being Sandler's favorite ratio. Oh, hypotenuse over opposite, 5/2. Tangent is opposite over adjacent. This one's going to need some cleanup work. That's 2/√21. So we multiply numerator and the denominator by √21, and we get 2√21. Sitting pretty over 21 because √21 times √21 is 1. I don't know why I put cosecant where cosine goes. Just having a moment here. Cosecant is the whole. It's 5/2. Cosine is adjacent over hypotenuse, right? A over h, which is √21 sitting pretty over 5. Secant is a funny guy. Says ha. Hypotenuse over adjacent is 5/√21. We multiply numerator and the denominator by √21. And we get 5/√21 sitting pretty over 21. And cotangent is AO. I'm off this morning, sorry. Adjacent is √21, opposite is 2. All right, moving forward. Number 10 would be something worth doing. Every single thing in this world exists over a 1. So I know that the cosecant of theta is x over 1, and I know that the cosecant ratio is Santa's favorite ratio, ho, because Santa goes ho, ho, ho. Anywho, this is enough information for me to draw a stinking triangle. Just put theta there. The hypotenuse is x, and the opposite side is 1. And we're supposed to find the tangent ratio. You know, the tangent ratio requires that I know opposite and adjacent. And I don't have the adjacent side, so I'm going to find the adjacent side. I'm going to call it a. A squared plus 1 squared is x squared. A squared is then x squared minus 1 squared, the 1 squared being 1. So a is simply the root of x squared minus 1, and there is absolutely nothing you can do with that. Don't do something silly like think it's x minus 1. If you do that, if you go look at the meme board, something dies. So don't be that kid. There's the adjacent side. So now I can find the actual tangent of theta. It is opposite, which is 1, sitting pretty over the adjacent length, which is the root of x squared minus 1. And normally we would clean that up, but I don't actually clean these up. There's a reason I don't actually clean them up. It's not that we can't. We can. I just choose not to. All right. Ooh. Missing angles. Given right triangle DOG. That's dog or God. I always thought it was funny that dog spelled backwards was God. And you know, a dog is your best friend. Something to do that. Let's see, we're told that DO is √29, O to G is 2, and we're supposed to find all remaining side lengths and missing angles. So I wouldn't have talked about this in class, so this is to build up for another day, is what that's for. All right, so we're supposed to find some missing sides and angles. Now here we are missing side A squared plus 2 squared is a root of 29 that must be squared. If you square a square root, you get the number inside. We've been there, done that, got the t-shirt. I'm going to take away 4 from 29 and get 25, which means side A must be 5. All right, so we have the missing sides. Now, we only have 2 angles we have to find. And you can pick any ratio you want, but I like the easy numbers here, the 2 and the 5. So I highlighted angle D, and 2's relationship to angle D is opposite, and 5's relationship to angle G is adjacent. So I happen to know that the tangent of angle D is 2/5. How does that help me figure out the angle? Well, the opposite of tangent is not cotangent. The opposite or inverse of tangent is something we call inverse tangent, or more preferably, arctangent. If I want a fixed tangent, I take the arctangent of both sides. And since this is a real triangle that exists in quadrant 1, tangent and arctangent annihilate each other and they free up angle D. So the measure of angle D is simply the arctangent of 2/5. And then I go pull up my TI-84 I'm going to put her in degree mode. You should too. But you're probably a kid who's not going to play along, and you're probably not even listening to the audio, to be quite honest with you. I don't know why you're like that, but you are. You could at least turn on the old subtitles. You're not going to do that either. 21 point, let's say, I really like to round to the second decimal, 21.8. Now, I know that a triangle has, at least a Euclidean triangle, has 180 degrees inside of it. So I'm going to do 180 minus 90. That's going to give me 90. And I'm going to take away 21.80. And what is that going to give me? That's going to give me what? 68.2. And there's my other angle. 68.20 degrees. Easy peasy lemon squeezy. Let's see, what do we got next? Let's do 15. A 450-foot cell tower has guy wires attached 200-foot, 20 foot from the top. Cell towers stand tall. The guy wires do not go all the way to the top. They are 20 feet from the top. And she was 450 foot tall, which means this has to be 430. The guy wires are 600 foot. A tower should form a right angle with the ground. I want to know the angle formed between the guy wires and the cell tower. So I'm after this angle right here. What is that angle? And it's not a hard question because what you have here is you have the hypotenuse, and in relationship to theta, you have the adjacent side. That's what you have. So what you actually have about theta is that you have the cosine ratio. The cosine of this unknown angle is simply 430 over 600. You could reduce the fraction if you wanted to, but you don't have to. Now, the opposite of cosine is arc cosine, so we take the arc or inverse cosine on both sides. A lot of teachers will say inverse cosine. I'm more a fan of arc cosine. I say arc cosine, arc being angular. Angular cosine is what I'm actually doing. And then I go push buttons in a TI-84. So second cosine, 430, sitting pretty over 600. I just got a message on my phone. I'm going to pause real quick. 44.22 degrees. I've climbed one of them big old towers several times. I've climbed several different towers in my life. And it's crazy how the weather changes. It's crazy how much those things actually move. When you're at the top of a 300-foot tower supported by guy wires, the thing sways back and forth about a foot. It's kind of interesting. A little bit unnerving at first, but you get used to it. Be right back. All right, where are we? We're on 17. In the accompanying diagram, a ladder leaning against the building makes an angle of 58 degrees with a level ground. If the distance from the foot of the ladder to the building is 6 feet, find the nearest foot. So they want me to round. How far up the building the ladder will reach? Well, that would be this guy right here. Not the hypotenuse. This is this guy right here. All right. So, you know, the hard part kids have with SOHCAHTOA is, first of all, spelling SOHCAHTOA. That's an issue. I should probably be writing this down every stinking problem I do. But kids also have a problem figuring out what opposite and adjacent are. And that comes from the adjacent side touches the angle, but it ain't the hypotenuse. This is adjacent, and this is opposite. Okay? So what I notice is that I have these two pieces. That's called the tangent ratio. So it turns out that the tangent of 58 degrees must equal x over 6. And this thing is so blasted easy to solve. You just 6 both sides and she's done. So it turns out 6 tangents of 58 degrees is my x value. And then I go push buttons in my TI-84, 6 tangents of 58, and I get about 9.6. And they want me to round that to the nearest foot, so I'm going to take that up to 10 foot. They want it in layman's terms. It is about 10 foot. All right, last one I'm going to do, number 19, the tree casts a shadow that is 20 foot long. So here's my beautiful tree. Shadows are created, with sunlight, right? And the shadow would lie on the ground. So there is a 20-foot shadow of a tree on the ground. The angle of elevation from the end of the shadow to the top of the tree is 66 degrees. That would go right here. This is the angle of the elevation. Determine the height of the tree to the nearest foot. Well, we'll just call that X. We call it H, whatever you want. And what we have here is we have the side opposite and we have the side adjacent. And it turns out that we have the tangent ratio. So the tangent of 66 degrees would be X over 20. And it's a lot like the last one I did. You just 20 both sides and you're one and done. It's a one-trick pony is all it is. 20 tangents of 66. And dadgummit, my tree my tree is about 44.92 feet tall. And they want us to round that to the nearest foot. 43 foot is the height of my tree. It's kind of a small tree, isn't it? And I feel like that's the last one I'm doing. So there you go. Hope you enjoyed.